Hi everyone, today we are going to learn about the properties of exponents again. We're going to remind ourselves of what the properties of exponents are, and then we're going to learn how to evaluate polynomial functions using direct substitution and what we call synthetic substitution. We're also going to be able to identify what makes a polynomial versus just a regular function. But before we get started, I would like you to please go ahead and complete both of these warm-ups. The first one is x equals 4x squared minus 15x, and the second one is 6 equals 11x squared minus 19x. So go ahead and pause the video and solve each of these equations, and I strongly recommend that you solve these equations by factoring. So when you have an answer, go ahead and restart the video. All right, here we go. The first thing that we want to do whenever we're solving a quadratic equation is we want it to equal 0. So what I'm going to do is I'm going to subtract x on both sides, and I now have 0 is equal to 4x squared minus 16x. Now what I want to do is I want to factor out a greatest common factor because 4 and 16 have at least a 4 in common, and both of these terms have in common an x. So I'm going to write 0 is equal to 4x times x minus 4. So I've divided out a 4 and an x from every single term, and now that I have it fully factored, I'm going to set each part containing a variable equal to 0. So I have 4x equals 0, dividing both sides by 4, I find that x is equal to 0, that's one solution. Or I have x minus 4 equals 0, which means that x equals 4. So those are my two solutions, x equals 0 or x equals 4. For number 2, I need to make this equation equal to 0, so I'm going to start off by subtracting 6 on both sides. So I have 0 is equal to 11x squared minus 19x minus 6. So what I want to do now is I'm going to break this apart into two parentheses. And the only way for me to get an 11x squared is for me to have an 11x and an x. So now I'm going to look at the factors of 6. And whenever I think of the factors of 6, I always think of 2 and 3 first, and then I think about 1 and 6. So my goal is to get a 19, and I know that 11 times 2 is 22, and 19 is 3 away from 22. So I'm going to, since 11 is on the outside, I'm going to put 2 on the outside, and I'm going to put 3 on the inside and verify once again. 11 times 2 is 22, and 3 times x is 3. So I want a negative 19, so I'm going to make that a negative 22 plus 3, and that's going to be equal to negative 19. So what I need is my 22 to be negative, so there's going to be a minus sign in front of 2, and I need my 3 to be positive, so there's going to be a plus sign in front of 3. So now that I have this quadratic factored, I'm going to set each parenthesis equal to 0. So now I have x is equal to negative 3 elevenths, or x is equal to 2. And those are my two solutions, x equals negative 3 elevenths, or x equals 2. Hopefully these two questions are familiar to you as they were on the 4.1 to 4.4 test. That was two of the questions that were on that test. So now I think we're ready for our lesson for today. And we have ourselves our learning objectives. The first objective of this lesson is to be able to say, I can use the properties of exponents to simplify expressions. So we're going to be working a lot with the properties of exponents with the next 3 units. And so I want to make sure that we certainly talk about those properties once again. Next, I want you to be able to say, I can determine whether a function is considered a polynomial. So there are specific rules that makes a function a polynomial, and we're going to talk about those. It'll typically deal with some kind of degree, and it's going to be also dealing with your exponents, things of that nature. So anyways, the next one is I can evaluate a polynomial using direct substitution and synthetic substitution. Synthetic substitution is going to be something very new, but a concept that you must make sure that you understand because it's going to really come into play by the end of this chapter. So we're going to learn how to evaluate. Evaluate essentially means to plug and chug. Plug in a number and chug out an answer. It means to plug and chug. That's what evaluate means. So let's go ahead and recap our properties of exponents. Very similar problems to what we did at the very beginning of the school year. So we have w to the 5th times w to the negative 8th times w to the 6th. And whenever you're multiplying powers with the same base, all you need to do is add the exponents. So that's exactly what we're going to do here. We're going to add our exponents. So this is w to the 5th plus negative 8th plus 6th power. This is a step that you do not need to show, but this is essentially what we are doing. We're adding all of our exponents together, and we will end up with the answer of w to the 3rd power. So once again, if you're multiplying two powers with the same base, you add your exponents. For letter B, C and D do not have the same base. They are completely different letters. So there's nothing for us to simplify inside of the parentheses. So what I'm going to do is I'm going to take this negative 2 and I'm going to distribute it to each exponent inside of the parentheses. So now I have c to the negative 2nd power divided by d to the negative 2 times negative 4, that's positive 8th power. So this was originally a c to the 1st, and I just multiplied that by negative 2. So that's the first thing that we're going to do. We distribute the negative 2 to all of your exponents. Now, anything with a negative exponent is not happy where it's located. So this c to the negative 2nd is not happy. It needs to be moved. So we're going to bring it down. So in the denominator, I have a c squared and a d to the 8th power. Now, I have to have something in the numerator. And what I'm going to do is I'm going to place a number 1 there as a placeholder, just to represent that I still have a fraction. And 1 over c squared d to the 8th is our answer. For letter C, we have a to the 3rd times b squared all over a to the 5th. So what I can do first is you can either take care of the a's or you can take care of your negative exponents. There's a lot of approaches for these problems, and the whole point is can you get the right answer. So what I'm going to do is I'm going to take care of my negative exponent by bringing it down, and so I'm left with b squared over a to the 3rd times a to the 5th. So I have just a b squared in the numerator, and a to the 3rd times a to the 5th. Well, just like example letter A, whenever you multiply two powers with the same base, you add the exponents. So I'm going to add a to the 3rd, I'm going to add 5 plus 3, and I'm going to end up with a to the 8th power. So I'm adding my exponents. Next, letter D. We have 7y squared times z to the 5th times y to the negative 4th times z to the negative 1st. Notice that there are no exponents on the outside of the parentheses. And since there are no exponents on the outside of the parentheses, we are simply going to drop our parentheses and then simplify like normal. So that is 7y squared times z to the 5th times y to the negative 4th times z to the negative 1st. So once again, if you do not see any exponents on the outside of your parentheses, you're simply going to drop your parentheses. And then now we're going to combine our like terms in a way. We're going to multiply our like letters times our like letters. So 7 is going to stay in front since there's no other whole numbers that we're multiplying. Y to the 2nd times y to the negative 4th. Adding those exponents, we have 2 plus negative 4. That's negative 2. So I have y to the negative 2nd. And then I'm going to add my z's. Z to the 5th times z to the negative 1st. That's 5 plus negative 1, which is 4. So we have z to the 4th power. We're almost done. You are not allowed to have final answers with negative exponents. So anything with a negative exponent needs to be moved. So I have 7 z to the 4th power all over y to the positive 2nd power, and that is your answer. For letter E, you have two choices. You can either distribute the exponent to every single term first, or you can simplify the inside of your parentheses first. I recommend taking care of your exponents first, but you have there's more than one way to solve these problems. So I'm going to distribute that exponent to every single term. Now be careful. You also need to distribute that exponent to the negative 2. That's a negative 2 to the 1st power. And on top of that, this is a negative 2 to the 3rd power, and the negative 2 is located inside of parentheses. So watch what I do here. I have a to the 6th times b to the negative 3rd all over parentheses negative 2 to the 3rd power times a to the 9th times b to the 6th. Now that I've distributed the exponents, what I can do now is I can take care of my negative exponents by bringing down the b to the negative third, and then I can also take care of the negative 2 to the third power, all at the same exact time. So I have, in the numerator, I have an a to the 6th all over negative 2 to the third power, which that is going to be the number 8, so negative 8. So I'm just going to change that to a negative 8, because that's negative 2 times negative 2 times negative 2. Then I have an a to the 9th, a b to the 6th, and now I have a b to the 3rd in the denominator. Now, whenever you divide powers with the same base, you subtract the exponents. And whichever exponent is larger, that's where your answer goes. So 9 minus 6 is 3. Since my denominator has more a's in it, that a to the 3rd is going to go into the denominator. And what's left in the numerator is nothing but 1. 1 represents our placeholder. Then I'm going to add my exponent, since we are multiplying two powers with the same base, and we end up with b to the 9th. This is our final answer because we have all positive exponents and we only have one of each letter represented. And finally, for letter F, we have two fractions. You have a choice. You can either simplify each fraction individually or you can multiply straight across. Personally, I like multiplying straight across and make this one fraction instead of working with two separate, but you do not have to do that. So I'm going to multiply straight across, and when I do that, this is like an x to the 1st, and I'm going to combine my x's. So x to the 1st times x to the 3rd, that's x to the 4th. So I have 7x to the 4th, y to the negative 1st. All over, in my denominator, I have x squared, and this y is being raised to the 1st power. So I'm going to add my exponents to make that y to the negative 3rd power. At this step, I'm going to move anything with a negative exponent. If there's a negative exponent on the bottom, it's going to move up. If there's a negative exponent in the numerator, we're going to move it down. So now I have 7x to the 4th power, y to the 3rd power, all over x squared y. And you can write it as y to the 1st if you would like. And now whenever you divide two powers with the same base, we're going to subtract the exponents, and the variable that has the most x's, or the side that has the most, that's where your answer will go. So in this case, we have 4 minus 2, which is 2. There are more x's in the numerator, so your answer is going to be x squared in the numerator. We have y to the 3rd over y to the 1st. 3 minus 1 is 2. There are more y's in the numerator, so we just have y squared. What happens in this case is our denominator goes away, so there's no reason to write over 1. We just leave it as 7x squared times y squared. And that is your answer. So those are the properties of exponents. And now we're going to be using those exponents to look at polynomial functions and to identify what a polynomial function is. So a polynomial is a monomial or a sum of multiple monomials. And remember that a monomial means that you're talking about a number, a letter, or a number times a letter. And that letter could have exponents. It may not have exponents. It just depends. So a polynomial function happens or occurs when n, which is your exponent, so n exponents, must be written as whole numbers. So one rule is that your exponents must be written as whole numbers. So if you see an exponent that is not a whole number, meaning that it is not, like you might see a fraction, or you might see a negative number, or you might see a root as an exponent, you have to have a whole number. So that is 0 and positive integers. Those are considered your whole numbers. So your exponents must be a whole number. And the coefficients have to be real numbers. So if you notice in your problems that you have a coefficient that is not real and it's imaginary, there's like some sort of funky I right next to it, then that means that it is not a polynomial function. So your leading term, a sub n, is your leading coefficient. It's the number that's in front of your highest degreed term. And your degree comes from your exponents. So n is considered the degree. And where this n is coming from is this expression right here. We have a sub n times x to the nth power. A sub n minus 1 is times n to the x to the n minus 1 power. That's what this is talking about. So the degree for the polynomial comes from your exponent that is the largest exponent that you see. So your degree comes from the largest exponent that you see. And then a sub 0 is what we call the constant. It's the number at the very end that does not have a variable next to it. So a constant does not have a variable attached. A polynomial is also written in standard form if its terms are written in descending order. So that means with respect to your exponents, you want it to go from largest to smallest with respect to your exponents. So you will be asked to rewrite your polynomials in descending order in standard form. And that's going to be your largest to smallest term from left to right. So it's going from left to right. So let's go ahead and look at our polynomial functions. These are a lot of functions that we're very familiar with. The first one is called a constant function. A constant function is your Hoy functions. It's your y equals a number functions. There are no variables that you will see. You'll see f of x is equal to negative 14. That's considered a constant function. And the degree is 0. And that's because technically, this function is equivalent to f of x is equal to negative 14x to the 0 power. Anything to the 0 power is just the number 1. So this is really negative 14 times 1, which is just negative 14. So whenever you see a constant function, the degree is 0. Linear functions are functions written in the form of y equals mx plus b. The degree of your exponent is the number 1, and that's what makes it a degree of 1. So an example would be like 5x minus 7. That would be considered a linear function. A quadratic function has the largest exponent of 2. So that means its degree is 2. And an example of a quadratic function would be like f of x is equal to 2x squared plus x minus 9. A cubic function has the largest exponent of 3. And an example would be x cubed minus x squared plus 3x. The degree in that case would be 3. Your quartic function is your highest degree of being 4. That's your degree right there. What you will see is a term that will be x to the 4th power, and it will be your largest exponent term. That's what you can expect to see. So we're going to use this information to define define polynomials, and we want to identify if something is considered a polynomial. So I'm going to look at each of these examples, and we're going to analyze each of them to figure out, is it considered a polynomial function or not. So what I would like you to do is I want you to look at each example. I'll do letter A and letter B for you, and then I want you to pause the video, and I want you to figure out, can you identify which one of these functions are considered polynomial functions? And if it is a polynomial function, I want you to make sure that it's rewritten in standard form. Then I want you to state its degree, the type of function that it is, and the leading coefficient. But if it's not a polynomial function, I want you to explain why. Tell me what you see. So in letter A, like I said, I'll do letter A and letter B for you to start. In letter A, we have f of x is equal to 3x cubed plus 4 times x to the 2.5 power minus 6x squared. So we have to ask ourselves, is this a polynomial function? Is every single exponent a whole number? Well, in this case, the answer is no, this is not a polynomial function. And what's wrong with it is that we have the term 4x to the 2.5 power. This 2.5 power ruins everything. This is not a whole number. So because it's not a whole number, no, this is not a polynomial function. Let's look at letter B. For letter B, we have f of x is equal to x squared plus 3.7x plus 9 times x to the 4th. Are all of my exponents positive numbers? Yes, they are. This is a positive 1 right here. Are all of my leading coefficients, are all my coefficients real numbers? Yes, the number 3.7 is a real number. It doesn't have a funky I next to it. So therefore, yes, this is considered a polynomial function. And so in order to rewrite it in standard form, we need to put the term with the highest degree first. So 9x to the 4th power will go first. Then we'll have plus x squared, then plus 3.7x. The degree of this function is our largest exponent. The degree is 4. The type, what kind of function is this? Is it linear, quadratic, cubic, quartic? Is quartic, and that's because our degree is 4. And our leading coefficient is the number that's in front of our x to the 4th power, and that's the number 9. So like I said to you before, I want you to go ahead and try to identify which one of these are considered polynomial functions. Do that on your own. And then when you have figured out what those answers are, go ahead and restart the video. All right, let's go ahead and look at letter C. For letter C, are all of our exponents whole numbers? Well, in this case, no. We have this negative first power. And that's not a positive integer. So 3x to the negative first power, this negative first power ruins everything. It's not a whole number. So therefore, since it is not a whole number, it is not a polynomial function. For letter D, I have g of x is equal to x times 2 to the x power minus 0.6 times x to the 5th power. Is this a polynomial function? Are all of my exponents whole numbers? In this case, no. We have 2 to the x power. This x is not a whole number. Could it be a whole number? Absolutely. Is it always a whole number? Not really. X could be any number, and we learned that back in middle school. X could be any number, so in this case, no, this is not considered a polynomial function. For letter E, let's look at all of our exponents. We have a 1 and we have a 3, so all of our exponents are whole numbers. Are all of our coefficients real? Is the square root of 3, is that a real number? Why, yes it is. Is the number pi a real number? Why, yes it is. It's ugly numbers, they're long decimal numbers, but they're real. Why are they real? Well, they don't have an I attached to it. There's no imaginary number attached to it. So yes, this is considered a polynomial function. So I'm going to rewrite this in standard form, making sure that my leading term, or the term that has the highest exponent, goes first. So pi x to the 3rd power will go in front. Then I'll have plus 7x, then minus the square root of 3. So my degree in this case is a 3. The type of function that it is cubic, and that's because it's being raised to the 3rd power. And the leading coefficient, that is pi. That's the number in front of the x cubed. Letter F. Are all of my exponents positive whole numbers? Well, in this case, the answer is no, and that's because of this 3 over x. Technically, this 3 over x really means 3x to the negative 1st power. And since it's 3x to the negative 1st power, it's not a whole number. It's a negative integer, not a positive integer. So therefore, in this case, no, this is not a polynomial function. Let's look at letter G. Letter G, we have 4, 2, nothing. All of our exponents are whole numbers. All of the coefficients in front are real. So yes, this is a polynomial function. So I'm going to rewrite this in standard form. And I'm just going to write this as y equals x to the 4th power minus 1/4 x squared plus 3. You know what? I didn't even need to rewrite it in standard form because it already was in standard form. So that was kind of cool. My degree in this case is 4. That means that the type of function that it is quartic. And my leading coefficient is 1. There is an invisible number 1 in front of that x to the 4th power. And finally, we have letter H. For letter H, I'm going to look at all of my exponents, and unfortunately, the square root of x ruins everything. So no, this is not a polynomial function. And this is something that I need you guys to know. The square root of x is actually equal to x to the 1/2 power. So since it's x to the 1/2 power, it's not a whole number. This x to the 1/2 power is something that I need you guys to please make sure that you remember. This is something that comes up in chapter 6 a lot. So just remember that the square root of x is x to the 1/2 power. And since it's not a whole number, this is not a polynomial function. All right, we have 2 more things to talk about, and then we are finished. The first one is called direct substitution. You will be expected to use both types of substitution on your test. So the first one is use direct substitution to evaluate a polynomial function for a given value of x. Whenever you see the word evaluate, it's asking you to plug in a number and come up with an answer. Using direct substitution. This is something that we've done for a long, long time. So I'm giving you a function and I'm saying that x is equal to 3. So I'm going to write this as f of 3. So f of 3 means a function of x when x is 3. This is a very fancy y, essentially. And that's f of 3 is equal to 2 times 3 to the 4th power minus 5 times 3 to the 3rd power minus 4 times 3 plus 8. You can plug that into your calculator exactly as you see it, or you can take care of each term individually. So 3 to the 4th power, that's 81. 81 times 2 is 162. 3 to the 3rd power is 27. 27 times 5 is 135. 4 times 3 is 12, and then plus 8. And if you were to put all of those numbers into your calculator, you would find that f of 3 is equal to 23. And if you were to write that as an ordered pair, the ordered pair would be 3, 23. For letter B, we're doing the exact same thing, but be careful whenever you are substituting in a negative value. Please make sure that you use parentheses whenever you are substituting. So I'm going to write y is equal to, and I'm going to replace all of my x's with a negative 2. So that's going to be negative 2 to the 4th power plus 2 times negative 2 to the 3rd power plus 3 times negative 2 squared minus 7. So you have to take care of your exponents first and then multiply your answer. So this is negative 2 to the 4th power, which is 16. Negative 2 to the 3rd power is negative 8. Negative 8 times 2, that's equal to negative 16. Negative 2 squared is 4. 4 times 3 is 12, and then minus 7. And if you were to put all of those values into your calculator, you would find that y equals 5. And if we were to write this as an ordered pair, it would be -2, 5. We substituted x, or let x equal -2 and substituted into the function and came up with y. That's considered direct substitution. This is something that we've been doing for a very long time. So now what we're going to do is we're going to evaluate using this thing called synthetic substitution. Synthetic substitution is kind of like, it does the process of substitution, of direct substitution, in a completely different way. There does exist some formal instructions on page 338 of your book if you want to look at example 3. But in general, what I'm about to show you is exactly what I need you to do on your test and for any other synthetic things that we do in chapter 5. So please follow along with everything that I do in example 4 and 5. So in example 4, we're going to use this thing called synthetic substitution. So my focus is going to be on just the coefficients that I see here, and I need to make sure that every single term is represented. So I'm going to write this down. Please make sure every degree is represented. So please make sure that every degree is represented. So what I mean by that is this is a cubic function, and I have 3, 2, 1, 0. All of my degrees are represented starting at 3 and working my way down. So from 3 to 0, there exists a term in all of those positions. So my focus is going to be on the coefficients. So what I'm going to do is I'm going to start off with the number that they want me to substitute in. That's the number 2. I'm going to draw a little box going around it, and then I'm going to write down all of the coefficients of each term, starting with -3, and then this is a number 1, then a -12, then a -5. Please do not write these numbers so close together to where it looks like we're talking about the number -31, -12, -5. Please don't do that. Leave some space in between your numbers. Next, in between your last two numbers, we're going to draw a vertical line and then a perpendicular line. And what's going to happen is this. I'm going to start off with my first term, which is -3. And I'm going to multiply 2 times -3, and I'm going to put my answer right here. That's -6. Now I'm going to add, going straight down. 1 minus 6 is -5. And I'm going to repeat the process. 2 times -5 is -10. -10 is going to go into this position. Now I'm going to add, going straight down, and I have -12 plus -10, which is -22. I'm going to repeat the process. 2 times -22 is -44. And that's going to go right here. And now I'm going to add it, going straight down. -5 plus -44 is -49, and there's your answer. So once again, what I did here is I brought down my first term, and that was -3. Then I multiplied the number I was supposed to substitute in, which is 2. 2 times -3, and I ended up with -6, and I put it just below the 1. And I added those terms going straight down and ended up with -5. Then I repeated the process. 2 times -5 is -10. -12 plus -10 is -22. Then 2 times -22 is -44. And -5 plus -44 is -49, and that is your answer. And you can write your answer as 2 -49. And you can also say that f of 2 is equal to -49 as well. So the whole point of that is just to get you familiar with a thing called synthetic substitution, and that's because synthetic is something that we're going to be working with a lot, especially towards the end of chapter 5. So let me go ahead and show you example number 5, and then we will certainly talk about examples 4 and 5 again next time I see you. So once again, I need to, I'm going to put in the number that I have, which is -2, and I need to make sure that every degree is represented. So I have 4, 3, 2, 0. So every degree is not represented. So I'm going to write f of x is equal to x to the 4th power. That's supposed to be a 4, sorry guys. X to the 4th power plus 2x to the 3rd power plus 3x squared. I'm missing my x term, so I'm going to put plus 0x and then minus 7. You put in a plus 0x because it's not changing the value of your original function. It's just changing the look of it, making sure that every degree is being represented. 4, 3, 2, 1, 0. Now I'm going to use all of my leading coefficients of each term, and I'm going to write down the number 1, then the number 2. Let's make sure it's clear for you. Then the number 3, then the number 0, and then the number -7. Between the last two terms, I'm going to draw a vertical line and then a horizontal line. The first thing I'm going to do is I'm going to bring down the number 1. And I'm going to write -2 times -2 times +1 is -2. And now I'm going to add going straight down. 2 minus 2 is 0. Then I'm going to multiply -2 times 0. And I'm going to put that answer up here. And that's going to be 0. And I'm going to add going straight down. 3 plus 0 is 3. Then I have -2 times 3 is -6, and I'm going to add going straight down, and I end up with -6. Then -2 times -6, that is 18. I'm sorry, that is 12, excuse me. Whew. And I'm going to add going straight down. -7 plus 12 is 5, and 5 is my answer. So you can write this as -2, 5, or you can write this as f of -2 is equal to 5. And look at what we had for example number 5. We had -2, 5. We substituted that in using synthetic substitution. We ended up with the answer of 5, and that was exactly what we did up here for direct substitution. So one of the cool things about synthetic substitution is that you're working with a lot easier of numbers, and you don't have to worry about calculator failure. Versus direct substitution, you're very dependent on your calculator and entering it in correctly. Both methods you will be responsible for knowing. So if you have any questions over anything, please make sure that you email me. We will certainly talk about this next time I see you. Otherwise, I hope you have a wonderful day.